Hi, this is your lucky sir. Group 13 elements, assignment number 5. Summer liquid among the following is. Summer liquid means gallium because from 30 degrees Celsius onwards it is liquid. So it is called summer liquid. Which of the following cannot exist? You can easily guess TLI3 because thallium with plus 1 oxidation state more stable. Plus 3 it can form but with fluorine type of high electronegative atoms. With iodine not possible. The hybridization of aluminium in AlH2O taken 6 clearly you can see there are 6 water molecules. So sp3d2 coordinate number 6. The bond angle not present in Al2Cl6. This is to be remembered. There is no 120 degrees because it is like sp3 hybridization. It cannot be with 120 degrees. Okay, now it is aluminium, two chlorines, bridges. If this is dative 1, this is again dative 1. Fine. Which of the following is weakest Lewis acid? BF3 because of maximum back bonding. Here back bonding is maximum there because of similar sizes of boron and fluorine, maximum back bonding is there. That's why this is the weakest Lewis acid. You can definitely get this question in your JEE entrance, NEET entrance exams. BF3 is a stronger Lewis acid than BCl3. Wrong statement, incorrect statement. The electronegativity of fluorine is greater than. This is right statement. In Al2Cl6, the covalency of aluminium is, just now I told you, the structure of this aluminium will be having 4 bonds. Chlorine with one more. Each aluminium with 4 bonds. AlCl3 fumes in moist air due to its hydrolysis to form HCl. Right? So, what is asking? Correct statement, sir. Aluminum metal is stable in dry air because of protective oxide layer, right? P-pi back bonding does not occur in halides of aluminium because of larger size, right? Anhydrous AlCl3 cannot be prepared by heating AlCl3 6H2O because all 6 water molecules won't go easily. They are coordinated. And this is also right. All are correct statements. Which of the following chloride is most unstable? Inert pair effect. Thallium is stable in plus 1 oxidation state. Yes. 10th question. The electropositive character increases from boron to aluminium and then decreases from aluminium to thallium because. Okay. That you can say because of ineffective. Okay, this is the problem with the d orbitals and f orbitals due to improper shielding of this. When boron undergoes sp3 hybridization, okay, now boron is having only electronic configuration like this, na? Helium 2s2 2p1. So this is a pair of electron. Here one electron. On excitation, it will become like this. Now here sp3 hybridization means one vacant orbital will be there. So which is the right option? Aluminium reacts with concentrated H2SO4 to liberate SO2 gas, right? In this process, the element H2SO4 that has changed its oxidation state from H2SO4 is plus 6, SO2 is plus 4. So the change is 2. Okay, now. So change is 2 for obviously sulfur. The reason for the formation of hydrogen bridge in B2H6 is because it is electron shortage of electrons, electron deficient compound. Neighboring structure is known to you. A metal X produces an oxide that and nitride on burning in air but do not liberate hydrogen with alkali. Another metal Y produces an oxide and nitride burning in air but liberates hydrogen with alkali. Then X and Y are. One interesting question. This kind of questions you can expect in IIT advanced examination. See, both they can form magnesium oxide, magnesium nitrate, aluminium oxide, aluminium nitrate. an oxide and a nitrate and burning in air, but do not liberate hydrogen with alkali. Okay, now alkali to hydrogen ivaddu ante, okay, na telugu, right? That is magnesium, because magnesium is basic in nature, so it won't react with alkali. But aluminum is amphoteric, so it will react with sodium hydroxide to liberate hydrogen gas. Sometimes mother tongue will come, obviously, not always father tongue. Then, when aluminum reacts with reagents in list 1, identify the products: aluminum with dilute HCl, aluminum chloride, and hydrogen gas. It must be aluminum. Na? Here options, I can see the options: aluminum, dilute HCl with AlCl3 and H2. A should be 3. So A should be 3 here, A should be 3. 2 options are there. We'll check the remaining options also. Dilute H2SO4, hydrogen gas should come, and aluminum sulfate. So B should be 4. Done. Remaining there is not check. Very dilute HNO3, aluminum nitrate, aluminum sulfate, concentrated is concentrated is aluminum sulfate. Very dilute HNO3 is first one. Now aluminum, these many properties are not mentioned in NCERT, so you can take this as some extra. 16th question. BCl3 does not exist because BCl3 does not exist as dimer because BCl3 will be having bridge. Okay, now this kind of structure you are expecting for hydrogen, B2H6. This is diborane. Why not here like this? Possible means very less possibilities. Does not exist as dimer. Like this it is not possible. If you take an aluminum, it is possible. Aluminum it is possible. Why not with boron? He is asking that question. Very simple. The vacant orbital in boron is not available because of the chlorine back bonding. So back bonding in BCl3. Aluminum can form, remember, boron cannot form because boron is very much involved in back bonding. Question number 17. An alkali metal hydride, sodium hydride, reacts with diborane in Y to give a tetrahedral compound, that is NaBH4. Reducing agent, the Y and Z in the above reaction are. Okay, now. NaBH4, only one option. This is ether solvent. Memory. Which of the following substance sublimes on heating? Sublimes on heating means AlCl3. Little memory. Okay, now you can't apply any logic here. The product formed in the reaction BCl3 plus H2O, you can expect very easily, that is BOH taken thrice plus 3HCl. BOH taken thrice is nothing but H3BO3, boric acid. Not a proton donor. 3 OH groups are there, but not a proton donor, right? 28th question. 20 after 19. How you went to 22? Why it has come 22? 22. So some 20. See here 21. This is 22. Something missing here. Okay. We'll check. Mr. Computer Operator, what are you doing, man? This is not at all fair. Okay, after 19 it should not be 22. It is 20, let us say. Okay. In Al to Cl6, the number of covalent and coordinate bonds are, see, Al, 1, 2 normal bonds, 1, 2 normal bonds. This is covalent, this is covalent. So 1, 2, 3, 4, 5, 6 are normal and coordinate bonds are 2. So it should be 3. Which of the following statement about AlCl3 is not correct? AlCl3 exists as a dimer. No, no. AlCl3 does not exist as a dimer. It exists as a dimer. Okay. It is a covalent compound. It involves in back bonding between chlorine and this is not correct. Which of the following is not correct? Anhydrous AlCl3 exists as Al2Cl6, right? Anhydrous AlCl3 sublimes on heating, right? Another say LCl3 fumes, right? Another say LCl3 is ionic, wrong. Okay, now this is covalent. 23rd question. Compounds of aluminum and gallium are covalent in anhydrous state and ionic in aqueous solutions. Aluminum plus 3 and Gm plus 3 have low heat of hydration values which can compensate their ionization energy values. When low heat of ionization is there, how can it compensate? Okay, now there is no meaning in this one. A is true, but R is false. In diborane, there are 4 terminal hydrogens and 2 bridge hydrogens. Absolutely. Diborane reacts with excess of methyl halide to give B2H2CH3 taken 4. This is also right. Right? Methyl halide. This point you remember because in recent years, I think 2022, this question asked B3N3H6 can be converted to B3N3H3R3. For this purpose, what we need to use? That is Grignard reagent. Not direct alkylation, you need to use Grignard reagent. This question asked in 2022. Check once. So here both A and R are correct and R is the correct explanation because only terminal hydrogens are replaced by methyl group. Which of the following statements is correct? 25th question we are discussing. BCl3, AlCl3 both are Lewis acids, correct, and BCl3 is stronger Lewis acid than AlCl3. Obviously, okay, because aluminium little bigger in size, boron can accept electron pair very quickly, very fast. Aluminium 3 chloride forms a dimer because dative bonds, coordinate bonds. Which option suits higher coordinate number? Which of the following properties of aluminium makes it useful for food packaging? Okay, now, aluminium actually nowadays we are not using. NCERT statement. Aluminium compounds nowadays we are not using because that is toxic. And your question, it is why it is using non-toxicity. Actually, aluminium compounds are not using. Okay, check once with NCERT. Aluminium compounds are not using nowadays because it is toxic. The hardest compound of boron is, okay, now hardest compound of boron is boron carbates. Boron carbates are very, very, very tough, like diamond, B4C3 type of compounds. You can use them. Heating an aqueous solution of aluminium chloride to dryness will give. Generally, it forms a heating an aqueous. This is the point. Aqueous solution means AlCl3. We are using aqueous solution means first it forms aluminium hydroxide on heating up to 1200 degrees Celsius. That gives you Al2O3. The hybridization of boron in the orthoboric acid is sp2, very regular, 3 regular bonds, OH, OH, OH. Slippery nature of orthoboric acid is due to hydrogen bonds. Boric acid H3BO3 has layer-like structure because of hydrogen bonding. The chloride of one of the following elements is stable covalent compound in solid state but ionic in their solutions. It is obviously aluminium. Okay, aqueous solutions ionic, regular covalent. In the reaction between boron and sodium hydroxide to liberate hydrogen gas, boron acts as, okay, now hydrogen H plus will be there, that is converting into H2, that is undergoing reduction. So you can say it is reducing agent because in sodium hydroxide H plus liberating hydrogen gas means H2. It is reducing. Boric acid is a polymer due to hydrogen bonding. Specify the coordination geometry around the ion hybridization of N and B atoms in 1:1 complex of BF3 and NH3. Actually, nitrogen lone pair is forming a bond with BF3. So both are sp3, both are with tetrahedral. Both sp3, both tetrahedral. Okay, now. Which of the following is not a Lewis acid? To function like Lewis acid, it should have vacant orbitals. Here all 6 water molecules are occupying. No chance. The hybridization of boron and oxygen atoms in boric acid respectively. Boron is sp2, oxygen is sp3. A triple question you can expect. Okay, now sp2 and sp2. No, it will be sp3. Orthoboric acid behaves as weak monobasic acid and giving H3O plus. And yes, Okay, an orthoboric acid behaves as weak monobasic acid. Actually, H3BO3 reacts with water and releases H plus ions and forming BOH4 minus, not plus, BOH4 minus. Select correct statements about H3BO3. H3BO3 will be having in solid state molecules are hydrogen bonded. We know about this. I repeat this. All are busy in hydrogen bonding, so it is not a proton donor. So these are some questions related to group 13. I will update group 14 today and tomorrow. You try to complete as many as you can. Then once if it is done, we'll move to organic chemistry. Right? Thank you. Like if you like, share if you care, etc. etc. Okay.